Hello and welcome back to the Math Mindset. Today we'll be looking at a fun number puzzle that goes as follows. Write 4 to the 8th plus 6 to the 8th plus 9 to the 8th is the product of two 4-digit numbers. So let's get straight to it. So if you notice, the first and the last terms in that expression, the bases of the exponents are perfect squares. 4 is a perfect square and 9 is a perfect square. So let's try and decompose the expression underlined in green and write it in the most primitive base possible. And by primitive, I mean a base that has the lowest value possible. So we can write 4 to the 8th as 2 squared to the 8th. 6 to the 8th we can't change, so we can write it as that. And 9 to the 8th, so 9 is 3 squared, so we can write that as 3 squared to the 8th. And now using our exponent rules, we can write this as 2 to the 16th. We can write that as 2 to the 16th. 6 to the 8th stays the same. And we can write 3 squared to the 8th as 3 to the 16th. Right? Now what do? We have this expression that I've just boxed in green right over here. And we need to do more with it somehow. Well, another key observation is crucial here. If you notice, 6 to the 8th, when you break down its prime factors and prime factorize it, it's a product of two powers of prime factors. It's a product of 2 to the 8th and 3 to the 8th. So we get some hope here. If we can write this expression, this entire expression boxed in green, as the product or sums of 2 to the 8th and 3 to the 8th, that would be perfect. So let's try and do that. 2 to the 16th is 2 to the 8th squared. 6 to the 8th is 2 to the 8th times 3 to the 8th. So I'll just write that down. Let me just fix that. It's 2 to the 8th times 3 to the 8th. And 3 to the 16th is 3 to the 8th squared. Now, this here in red seems a bit cluttered. So let's replace 2 to the 8th and 3 to the 8th with variables. So let's define those variables. We can say 2 to the 8th will be A and 3 to the 8th will be B. So let's rewrite our expression that's in red right now. So the expression in red then becomes A squared plus AB plus B squared. Right? Now, when I look at this expression, I'm immediately reminded of the identity A squared plus 2AB plus B squared, because it looks so similar. And this is equal to A plus B whole squared. And so I'm wondering that is it possible to use A plus B all squared, this expression, and use it to write A squared plus AB plus B squared in a different way that'll give us something to work with, something more to work with. So let's try that. So we can write A squared plus AB plus B squared as A plus B. We can write it as A plus B all squared minus AB, because we have one AB over here instead of 2. So now let's substitute our values for A and B back in to see if we can identify something else that will take this further. So when we substitute our values for A and B back in, we get that the expression becomes 2 to the 8th plus 3 to the 8th squared minus 2 to the 8th times 3 to the 8th, which is 6 to the 8th. And this right here is a difference of squares. We have a perfect square right here, and we have another perfect square right here, because this is even. So this whole thing is a perfect square. So now we will use the difference of squares identity to solve this, or to rather decompose it even further. So using difference of squares, so using that identity, we have that the expression that's boxed in green right here, that becomes 2 to the 8th plus 3 to the 8th. So that's the first expression when you take the square root of it, minus the square root of 6 to the 8th, which is 6 to the 4th. And you do the same thing except it's plus instead of minus. So 2 to the 8th plus 3 to the 8th plus 6 to the 4th. And so now if we find the actual values of all of these exponents, add and then subtract, we might have our answer. So let's just do that. So this box right over here, 2 to the 8th is 256. 3 to the 8th is 3 to the 4th squared. 3 to the 4th is 81. 81 squared is 6,561. Let me just make sure. 81 times 81, 864. 1, 6. Yep, it is. So that is 6561. And 6 to the 4th is 1296. And now we have the same numbers on the other set of parentheses, just different operations applied to them. So this is 256 plus 6561 plus 1296. So now we just have to find the values of the numerical expressions inside the parentheses, and we'll be done. So let's do that. So let's find the value of the expression in this parentheses right over here. So 6561 plus 256, that is equal to 6,817. Now if you subtract 1,296, we get 1, 2, this becomes a 7, 5, 5. So this right over here equals 5521. And now we find the value for this parenthetical expression right over here. So this is equal to 6561 plus 1296 plus 256. So 1 plus 6 plus 6, that's 13. 1 plus 6 is 7. 7 plus 9 is 16. 16 plus 5 is 21. 2 plus 5 is 7. 7 plus 2 is 9. 2 plus 5 is 7. So 9 plus 2 is 11. And 1 plus 6 plus 1 is 8. So we have our two numbers. 5,521 and 8,113. So we can definitely conclude that 4 to the 8th plus 6 to the 8th plus 9 to the 8th is equal to 8,113 times 5,521. And that is our final answer. If you enjoyed this video, don't forget to like, share this video with people you know, and comment your suggestions and thoughts down below. Don't forget to subscribe, and I'll see you in the next video. Goodbye. In the meantime, go watch this video, or if you have the time, check out that playlist. But don't forget to subscribe.